Here's what I saw on Reddit. If you take the alternating sums of the number, and that is divisible by 11, the whole thing is divisible by 11. Hi, I'm Sarah. I've been a science and math teacher for 20 years. I like to make math fun, engaging, and not so scary for everybody. If you want more practice problems, more information, tutoring sessions, click the link and do the stuff. There's lots of little tricks like that, right? Like if you add up all the digits in a number and that sum is divisible by 3, the whole number is divisible by 3. Same thing with 9. So something like 459. 4 plus 5 is 9. 9 plus 9 is 18. 18 is divisible by 9, so 459 is divisible by 9. It's also divisible by 3, so 459 is divisible by 3. For 6, if it's divisible by 3 and by 2, then it's divisible by 6. Divisible by 5 is if it ends in a 5 or a 0. And when we're talking about these divisibility rules, we're talking about like with factors, right? If we were talking about fractions or decimals, like everything can be divided basically, right? But we're talking about evenly divisible numbers. Okay, that pesky 11. 11s are really tricky because they're not as simple and straightforward, I don't think. So with divisibility rules, I usually just kind of stop at 10 because you don't necessarily, especially if you're doing like prime factorization, but 11 is one, it's a prime number. Sometimes it is important to see if a big number is divisible by 11. So let's get into it. 4, 3, 7, 5, 8, and we're going to see if it's divisible by 11, question mark. So is 43,758 divisible by 11? So alternating sums. Now on all of the examples that they gave, it always started with subtraction. When we're doing these little investigations, we want to always double check to see like the different variables. I don't like saying variables, but the different, I can't even say factors. Different things. I guess things is the best. Considerations, things to take into consideration. Yeah. Does it have to start with subtraction? Let's see. So I know that this one works out because I worked it out ahead of time. Okay. So 4 minus 3, remember we're alternating, plus 7 minus 5 plus 8. 4 minus 3 is 1. 1 plus 7 is 8. 8 minus 5 is 3. 3 plus 8 is 11. And 11 is divisible by 11. So 4, 3, 7, 5, 8 is divisible by 11. And we get 4, 3, 7, 5, 8 divided by 11. And it's 3,978. Great. So now let's check. So we know that this way it works. But we want to make sure a pattern, you need to have multiple instances that all meet the criteria in order to establish a pattern. We can say that that worked. Great. But what we want to make sure is we want to double check, does it have to start with subtraction first? And the other thing we want to check is we would want to check a few different numbers, right? A few different larger numbers, like maybe with 4 digits or 10 digits or something like that. We may or may not get into that, but let's check it first with just, all right, so let's see if I do 4 plus 3 minus 7 plus 5 minus 8. What does that get us? Okay, so 7 minus 7 is 0. 0 plus 5 is 5. 5 minus 8 is -3. That doesn't work. So I think that answers our question of like, does it have to subtract first? So far, signs are pointing to yes, because -3 is not divisible by 11. So let's now try, another 6-digit number. Oh, you know what though? I'm going to make sure, because I want to try it with a number that I know is divisible by 11. So the way we do that is we're going to do, take a big number, like, I don't know, give me a 4-digit number.
3247.
3247 times 11 is 35717. Okay, so we're just getting this because we know that this number, this 35717, we know that is divisible by 11 because I just got it by multiplying by 11. That isn't what we're necessarily concerned with. What we're concerned with is this method, right? We're just double checking this method of determining if it is divisible by 11. Again, we know it is, so we're just checking the pattern, right? Okay, so we did establish that it has to be subtraction first. So we've got 3 minus 5 plus 7 minus 1 plus 7. And we get 3 minus 5 is -2, plus 7 is 5. 5 minus 1 is 4. 4 plus 7 is 11. Interesting. All right, so that one checks out. All right, let's try one number that's smaller and one number that's bigger. So let's do 11 times, okay, let's look at 286. So 286 is divisible by 11. So we would do 2 minus 8 plus 6. So 2 minus 8 is -6. -6 plus 6 is 0. And 0 is divisible by 11. I mean, it gives you 0, but it's divisible by 11. And 286 divided by 11 is 26. Okay? All right, so it checks out with a smaller number. Let's check it out with a bigger number. Let's go with 3,484,778 divided by 11. Okay, I'm trying to see, is it divisible by 11? But we're going to check our pattern, right? So we start off with subtraction. So we have 3 minus 4 plus 8 minus 4 plus 7 minus 7 plus 8. Okay, 3 minus 4, that's -1. Plus 8 is +7. Minus 4 is 3. Plus 7 is 10. I can already see that's going to work. Dang it. 10 minus 7 is 3. 3 plus 8 is 11. That is quite a little pattern. Curious to know why it works that way. And who discovered this, right? Who figured this out? That the alternating sums. Math is wild. I like it. I'd probably just put it in my calculator, but it's still a pretty cool thing. It's mathed up.